In this tutorial, I'm going to go through the different modeling tools that I use to develop the Mashrabiya bracer for my submission to the Pinshape Fashion competition. So Pinshape is an online 3D printing resource that you guys can utilize and engage to develop some of your guys' 3D prints. Obviously, if you guys just follow the link on the video, you guys can get there. For this particular design, I actually utilized 3 different pieces of software after I 3D scanned my own body. The piece of software are Rhinoceros 3D, and then there are 2 plugins for that particular software, Grasshopper 3D and T-Splines. Now, utilizing that software, I was able to take and develop this 3D pattern, and then utilizing T-Splines, I was then able to develop and give this sort of a closed thickness. So the design actually is a critique of some of the cultural structures that we find in architecture. I have an architectural background, and so Mashrabiya is a Middle Eastern architectural screen that separates the men and women's quarters. In the submission here, I added an image of an actual parametric version of this that I can show you in the file here in a moment. But what we're looking at is taking, and we have needs for transparency, needs for privacy, and then needs for ventilation. And so we look at the diagram for that in a traditional structure. We see that we have this sort of zone where we get daylight in, and that helps light these sort of deep dark spaces. Then we have the privacy zone. We're trying to mask the identity of the people actually behind the screen, and then the ventilation. Obviously, this is a hot, arid climate, so we want to make sure that we're able to move air through this architectural facade or architectural screen. Now, in the development of the piece, what we're actually looking at having here is we're taking this and translating this into a fashion item. And so we're taking the architecture and something that you really can't take with you, that you can't move around, and then embedding that into a fashion piece. So this, as culture has become more global and there's a desire for you to express your culture through your fashion, this becomes an implement that really starts to become a cultural critique. All right, then as we move into the modeling of the actual piece, I'm not going to go through all of the really advanced tools in here. I'm just going to talk about them very briefly. We have Grasshopper here that I used to develop the space frame, and we have a proximity sensor. So this is based on the proximity of this geometry. Oops, I'm not sure what happened there. Based on the proximity of this geometry to this geometry, it sets the opacity. So the farther away it is, the greater the aperture. And then as it gets closer, it gets tighter. And then if it gets too close, it starts to open up again. And that's where we start to see transparency for daylighting, closing up for privacy, and then opening back up for ventilation. Here's the Grasshopper definition. Go ahead and close that down. And then from there, what I've done is I've baked that out. That gives us a set of curves that then we can translate onto our surface. And I'm going to do that by using the flow along surface. And the way that that works is you have a base surface, and so think of like a piece of paper. We have this unrolled, and we're going to wrap that around this surface that I've generated here. And so it's going to ask us to grab a corner. I will then, and so based on the corner that you grab over here and the corner you grab on this, it sets whichever size is the front or the back of your map. And then from there we can run our T-Splines operation. Okay, but I'm going to go ahead, I'll just create a new document. All right, and then I'm going to go ahead and just work small objects in inches. It doesn't matter what system you're working in. When you translate it into an STL, it'll be able to figure this out. What I really want to go through, though, is just talking briefly about the concepts behind 3D printing. When you're going through and doing this and developing something for 3D print, the really important principal thing is to think of a water balloon or a watertight object. Why think of a water balloon? Well, when you have a water balloon, you have a very distinct interior and a distinct exterior. The water's on the inside, and you have a thin membrane that surrounds that. And then if you don't, as soon as that membrane is interrupted, then you get water everywhere and you make a big mess. And that's really what happens in the computer. If you don't have a very distinct interior, then it doesn't know where to put the material when you're 3D printing, and it doesn't know what's inside or what's outside. So it's really the most important principle. Watertight objects, think water balloon when you're going through it. All right, so now if I just hit Control-N, I'm going to go ahead and work in small objects, like I said. For T-Splines, what it will do is it'll automatically do a lot of the information for us, so we can go ahead and just draw curves. The way we look at this, all of our curve tools are going to be right in here. We can just draw all this geometry and say, let's take this and we'll just do an array of this, and we want to do a really ugly flower here. So we do an array polar, set the center, and then we can do let's go 10, 360, and we have this pattern here. And so if this is the thing we wanted to do, say we're developing a Christmas ornament or something like that, we can then just go T-Splines, from curves, pipe. Now there's a couple settings in here. We can set the radius, set that to be like 0.5, and then we can set the joint type from box, which will be the default, to smooth. And so we hit enter. All right, and if we just shade that, now I have a nice clean geometry. This is one surface, and then we just mesh that because we need to basically enable the machine to talk to the printer. Rhino is a NURBS modeler that's non-uniform rationalized B-splines, which basically means that it's based on mathematics, and which means that there is not really any granularity to that. And so we turn this into a polygonalized mesh that gives us very specific coordinates, and it makes things really ideal for talking to machines that have to fabricate things with real coordinate values. So we'll go ahead and mesh that, and then when we select our mesh, automatically it's going to be a closed mesh. And so you can come in here. You can just leave those mesh settings like the one I just showed. This is a fully 3D printable object, so you can just take this and export it. You just select that, export as an STL, stereolithography. From there, save, and it's going to prompt you if you want to do it in binary or ASCII. If you just want to do binary, it's a little smaller file, a lot easier for you to upload. You never want to export open objects. That's just going to be bad karma. Any open objects that you submit online or that you try and give to a 3D printer, it'll automatically just reject those. So don't bother. Hit OK. All right, and then you're good to go.